Newton's first law. Every object in a state of uniform motion tends to remain in that state of motion unless an external force is applied to it. The first law of motion tends to be recognized as Galileo's concept of inertia, or in other words, the law of inertia. There are two individual parts to this statement. The first predicts the behavior of the objects at rest, and the second predicts the behavior of objects in motion. If an object is at rest, it will continue in that equal state of rest. If an object is in motion with an eastward velocity of 10 meters per second, it will continue in that equal state of motion 10 meters per second east. If it continues in motion with a leftward velocity of 5 meters per second, the object will continue in that equal state of motion 5 meters per second left. The state of being in motion is maintained when an unbalanced force is not acted upon the object. Also, every object can resist changes in their state of motion.
Newton's second law. The relationship between an object's mass, m, its acceleration, a, and the applied force, F, is F equals ma. Acceleration and force are vectors, as indicated by their symbols being displayed in slant, bold font. I'm supposed to say that. Okay. In this law, the direction of the force vector is the same as the direction of the acceleration vector. The second law of motion is the most important of the three laws, since it allows you to complete calculations of dynamics. First, how velocities change when forces are applied to them. But there's one fundamental difference between Newton's second law and Aristotle's dynamic. According to Newton, forces only cause a change in velocity and acceleration. This is usually expressed by Newton's formula F equals ma, but by Aristotle's formula F equals mv. According to Aristotle, if a force is present, then a velocity is present as well. But according to Newton, an object with a specific velocity maintains that velocity, unless a force is acted upon it, causing an acceleration or a change in the velocity. Aristotle's view seems to be looked upon with common sense. This is only because of a failure to appreciate the roles that frictional forces play. If appreciation is taken for each of the forces acting in a certain situation, then the dynamics of Galileo and Newton are found to be looked upon with the same observations.
Newton's third law. For every action, there is an equal and opposite reaction. The statement explains that in every interaction, there is a pair of forces acting on the two interacting objects. The size of the forces on the first object equals the size of the force on the second object. An example of how to explain Newton's third law is by what happens when you step off a boat and onto the bank of a lake. You move into the direction of the shore, the boat moves in the opposite direction, and could potentially cause you to fall in the water.
He needs his box.
What are you doing? A common misconception is that rockets accelerate because the gases rushing out of the engine push against the ground of the atmosphere, which is not true. Instead, what happens is that a rocket exerts a strong force on the gases, continually expelling them, and the gases exert an equal and opposite force on the rocket. It is the latter force which propels the rocket forward, the force exerted on the rocket by the gases. In addition, a space vehicle is maneuvered in empty space by firing its rockets in the direction opposite to that which it needs to accelerate. Once the rocket pushes the gases in one direction, those gases push back on the rocket in the opposite direction.
Good outro.
Yeah.
She will put in comedy things and like
I will?
videos.
I'm gonna
You
put
did that last time.
I'm gonna put effort into this.
That's-
What?